metallic and non-metallic property of elements along a column and along a period. We have 118 elements. These 118 elements have been placed in 18 columns and 7 periods in the periodic table. Vertical columns are called groups, and horizontal rows are called periods. In the modern periodic table, there are 18 columns and 7 periods. These 118 elements have been placed in 18 columns and 7 periods in the modern periodic table. Today's lesson, metallic and non-metallic property along a column and along a period. This is today's lesson. In this lesson, we are going to learn general concept of metals and non-metals, electronic concept of metals and non-metals, and then change of metallic property along a period and along a column according to electronic concept. And finally, submetals or metalloids. So let's begin. Let's see which elements are metals according to general concept. The elements which are glossy or lustrous or shiny, and the elements that conduct heat and electricity. The elements that produce metallic sound. When strike. So the elements that are glossy, conduct heat and electricity, and produce metallic sound when struck. Those elements are called metals according to general concept. And what are non-metals according to general concept? Non-metals, not glossy, cannot conduct heat and electricity. Non-metals are not able to produce metallic sound. So the elements that are not glossy, cannot conduct heat and electricity, cannot produce metallic sound when struck, those elements are called non-metals. Metals and non-metals according to general concept. Now let's move on to the next point. Electronic concept of metals and non-metals. Let's see the matter in detail. We know sodium is a kind of metal that donates electron during reaction. Again, we know calcium is a kind of metal that produces electrons during chemical reaction. Again, aluminum that yields electrons during chemical reaction. So we can say that the elements that can produce electrons during chemical reaction, those elements are called metals. Electron producers are metals. Now let's see about non-metals. We know chlorine accepts electron during chemical reaction. Again, oxygen accepts electrons during chemical reaction. Again, nitrogen accepts electron and nitride ion is formed. So, what will be the definition of nonmetals according to electronic concept? The elements that can accept electron during chemical reaction are called nonmetals. Simply, metals are electron donors and nonmetals are electron acceptors during chemical reaction. Let's move on to the next point. Now, change of metallic property along a column. Let's see the matter. First of all, let's write elements that belong to column 1: hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Atomic number of hydrogen is 1, lithium 3, sodium 11, potassium 19, rubidium 35, cesium 55, and francium 87. What is the change of metallic property along a column? For example, column 1. Here, hydrogen is a kind of non-metal which is specially placed in column 1. Let's see the elements except hydrogen. Here, lithium. Electronic configuration is 1s2, 2s1. Lithium has two shells. First shell contains 2 electrons. Second shell contains 1 electron. Now let's see electronic configuration of sodium. Sodium 11, 1s2, 2s2, 2p6, 3s1. Sodium has 1, 2, 3. 3 shells. Nucleus. First shell contains 2 electrons. Second shell contains 8 electrons. And third shell contains 1 electron. This is electronic configuration of sodium. Again, let's see electronic configuration of potassium. Potassium 19. 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. Potassium has 4 energy levels. Nucleus. First level contains 2 electrons. Second energy level contains 8 electrons. Third energy level contains 8 electrons. And fourth energy level contains 1 electron. Now, what is the change of metallic property along a column? We know the elements that can donate electrons are called metals. That is, the elements that can donate electrons easily, that will be more metallic. Here, for lithium, outermost shell electron and nucleus, distance is very low. That is why lithium cannot donate this electron easily, because this electron which is nearer to nucleus is strongly bonded to the nucleus. That is why this is not a good metal. But in case of sodium, we see the outermost shell electron and nucleus distance is a bit higher. That is why the outermost shell electron is comparatively loosely bonded to the nucleus. That is why sodium can donate its outermost shell electron comparatively easily than lithium. So sodium is more metallic than lithium. Now let's see about potassium. We see that the outermost shell electron in potassium is residing in the fourth level. So here distance is more greater than sodium and then lithium. So potassium can donate these electrons more easily, because here outermost shell electron is loosely bonded to the nucleus because of the longer distance. As from top to bottom atomic sizes increase, the distance between nucleus and outermost shell electron increases, and as a result, from top to bottom elements can donate electrons easily from its outermost shell. So from top to bottom, metallic property increases according to electronic concept, because from top to bottom metallic size increases, distance between nucleus and outermost shell electron increases, and as a result elements can donate electrons easily. That is, metallic property from top to bottom increases, and from bottom to top metallic property decreases. This is metallic property along a column. Now let's see metallic property along a period. Now the point is metallic property along a period. Let's write elements that belong to third period. For example, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and finally argon. Atomic number of sodium is 11, 12 for magnesium, this is 13, 14, 15 for phosphorus, sulfur 16, 17, 18 for argon. What is the fashion of changing metallic property from left to right along a period? We know from left to right along a period, atomic sizes decrease. From left to right, atomic sizes of elements decrease. When atomic sizes decrease from left to right, then distance between nucleus and outermost shell electron decreases gradually from left to right. That is, from left to right, the outermost shell electron gets strongly bonded to the nucleus because of the lower distance, and as a result, from left to right, elements cannot donate electrons easily. Electron donating character decreases. So we can say that from left to right, metallic property decreases, and at the same time, from right to left, non-metallic property decreases. From left to right, metallic property decreases, but non-metallic property increases. That is, metallic property decreases and non-metallic property increases. This is change of metallic property and non-metallic property along a period. Along a period, from left to right, metallic property decreases and non-metallic property increases. Here, argon is taken out of consideration because argon is a kind of inert element. It has no electron donating and accepting character. Except argon, from sodium to chlorine, metallic property decreases from left to right and non-metallic property increases from left to right. Because here we see that electronegativity of sulfur is lower than chlorine. Chlorine's electronegativity is higher than sulfur. That is, electron accepting character increases from left to right. Non-metallic property increases. Electronegativity of sulfur is 2.1, chlorine is 3.0. Electron accepting character. This is about metallic and non-metallic property along a column and along a period. Let's move on to the next point. Now the point is submetals or metalloids. Let's write a part of periodic table. Column 13, boron, aluminium, gallium, indium, thallium, nihonium. Column 14, carbon, silicon, germanium, tin, lead, flerovium. Column 15, nitrogen, phosphorus, arsenic, antimony, bismuth, moscovium. Column 16, oxygen, sulfur, selenium, tellurium, polonium, livermorium. From column 13, this is submetal or metalloid. Column 14, silicon is a kind of submetal or metalloid. Then germanium, arsenic. After that, antimony and tellurium. These elements are mostly submetals or metalloids. The elements that show sometimes metallic property and sometimes non-metallic property. Those elements are called submetals or metalloids. Elements having metallic and non-metallic property are called submetals or metalloids. This is all about metallic and non-metallic property along a column and along a period. If this lesson benefits you a bit, please subscribe to the channel. No more today. Thank you very much.